Good morning to all. Today, we would like to talk about the digital system. Indeed, the digital system is extensively used in automobile industry. Indeed, it is the first domain that has employed the digital system for various control operations. And the control operations may be speed control, or it may be the driver alert, it may be fuel indication, or it may be some other operations that are internal to the vehicle. And nowadays we are finding the car that is having all smart controls, which is capable of doing the self driving without the help of external driver, and it is able to take the decisions when it should move and when it should stop, when it should apply the brakes. And automatic parking is nowadays identifying before entering into the parking slot. It will recognize where the vehicle has to park and go to that place and park itself. Okay, so the digital system is aimed to provide solutions to the real world problems. As I told, automobile industry is the biggest domain that is employing the digital system. Anti-brake, anti-brake skidding system, ABS system, etc. are employing these digital gadgets for doing the various operations. Okay, some of them are locking of the door, whether the doors are properly locked or any one of the door is open, and if it is open, it is going to alert the driver, and the driver is capable of knowing which door is open, and accordingly he will take the proper care, because nowadays a single control is operating all the doors, but still it's capable of telling which door is properly locked or unlocked. In fact, if any door is opened during the driving, it is fatal to the entire the vehicle as well as the people who are traveling in the vehicle. Another one is automatic speed control system. It is able to identify the traffic density, and based upon the traffic density it can apply the various levels of speeds, and so that the fuel consumption is going to be efficient, and it is able to make the proper decisions when to speed up and when to apply the brakes. And if the it is the road is clear, and it will apply the highest speed, and if the very much traffic is associated, then it will apply the associated brakes. And smart board display, nowadays it's going to be a very handy system. It's able to collect all the information associated with the driving, the way the driver is driving, the vehicle sensors, how they are behaving. All that information is collected and sent to the place where any corrections are needed. They will do apply the necessary corrections. The dashboard is going to tell what was the vehicles that are coming back, and how many vehicles are there in the forward direction, what is the traffic density, and which road is congestion and which road is free, and it is able to provide the proper information using the GPS associated system. And this is driver alert system. It is going to tell what is the behavior of the driver by sensing how the driver is handling the steering and how the driver is in how much alert the driver is having, etc. So image processing with the proper digital control is capable of sensing the behavior of the driver, and it is able to alert the driver by playing the music. And some drivers are having specific choice that particular music is played so that driver is become alert and drive it, or giving some sounds and that will make the driver will be attentive and do the proper driving. Or the third way, it appears the driver is unable to take the proper decisions and the driver appears to be drowsy and it feels that he needs the proper rest. And what the control system will do is it will make the vehicle to park or parking in a safe place and allow the driver to take the rest. And the smart energy system is capable of controlling the gadgets remotely without going to the actual location of the gadget. It is able to on or off the respective gadget. And this energy in the by the way, these controls are capable of utilizing energy properly and avoiding any wastage or avoiding any excess power consumption, etc. And simple mobile is capable of performing switch on switch off the respective gadget and see that it's going to work. Right, the today contents, we would like to focus on what are the various types of the systems, digital systems, and what is the process of solving the real world problems, and some examples associated with this real world problems and how the digital system is useful for solving these real world problems. The one of the problem appears to be headlight warning system, means if anything is abnormal, warning is made, and if everything is okay, there is no need to have any warning. Similarly, alerting, if any door is open, then it is providing the alert, and if all the doors are properly locked, there is no alert. And the railway signaling system, it's going to assign the platform for incoming train before it is actually arrived into the station. And the furnace system is able to provide the proper temperature control at various places of the furnace. So it is capable of adjusting the temperature as per the furnace requirement, and it can either raise the temperature or it can reduce the temperature based upon the requirement. And finally, for all the physical systems, we derive the Boolean or control expression and solve that control expression to provide the solution. Okay. Now we would like to see a simple application. We would like to see what are the various types of systems, digital systems, and then take one example, etc. The moment we say it is a system is associated with the set of inputs as well as outputs. And the output of the system is depend on the behavior of the system. So we can say y equal to f of I. Based on how many inputs and how many outputs we are having uh, various types of digital systems. One is called single input, single output system. A simple inverter or a NOT gate is having one input and one output. So it is called as single input and single output system. On the other hand, we can have many inputs are there, but only many inputs are there and only single output, or single input is there, there will be many outputs, and finally multiple inputs as well as multiple outputs. We consider the second case, single input and multiple outputs. It's an example for the demultiplexer. The demultiplexer is having one input and several outputs. This input is routed to one of the output based upon the control signals. So this is an example for single input and multiple output systems. And multiple inputs and single output system, we can have a simple digital gate, AND gate. Let us say it is having 3 inputs and 1 output. Number of inputs are more and output is only 1. It will come under multi-input single output system. And finally, multi-input multi-output system, we consider the half adder which will have 2 inputs, let us say AB, and 2 outputs. One output is called as sum, another output is called as carry. So we can say in broad, the digital system can be 4 types based on the number of inputs and the number of outputs. They can be single input single output system, single input multi output system, multi input single output system, and finally multi input multi output system. We have seen 4 cases: NOT, demultiplexer, and half adder. Now we will further throw some light on the system behavior. Based on how the system is responding, the digital systems are broadly categorized as combinational systems and sequential systems. In the case of combinational circuits or combinational functions or combinational systems, the current output depends only on current input. The current output depend on only current input. That is y equal to f of I. On the other hand, another type of digital systems which are more or less follow the human behavior, and our human behavior, the response will depend on the current inputs as well as the previous impression on the person. Or we can say here the current output depend on current inputs as well as input or inputs based upon the system. Current output, previous output, current input as well as previous output. Again, output or outputs based upon the nature of the system. And the system which is having this behavior is called as sequential system. For example, in the market, in the very gathering, one of the friends says hello, and the response from your side is not only depend on this hello input, but also what is the impression on the person. Impression is basically the previous interaction with that person. You can say previous output. So your response, if that person appears to be very friendly with you, your response saying hello is totally different. If you are having an impression about that person who has not good with you or not properly behaved with you, then your response will be totally different. So the words are same, the way how we pronounce is going to communicate to that person, and what is your intention. Context, based on the context, your response may be simple as hello, or your response may be some other way. Okay, this is called as what? Sequential behavior. And it is interesting to note that if you are able to make the sequential system, the current output is independent of the state only on the inputs it is going to associate, then that sequential system is going to become combinational system. In other words, the sequential system, you consider it as a uh, biggest set, and the combinational system is going to be a subset. So combinational system is a subset of sequential system. So this is combinational, and this entire thing is going to be sequential. So what we do is we study initially about this combinational system, and after that what is contributing to the state, that is nothing but a memory element or a flip-flop, and we analyze the flip-flops later while discussing about sequential circuit. In other words, entire our preparation is focused on the combinational system initially, and once the combinational system is completely exposed, then we talk about the sequential system. Now we talk about the real world problems and how to solve the real world problems, and what is the process, and what are the examples, etc. So for what we have seen, what are the various types of digital system? Single input, single output, single input, multi output, multi input, single output, multi input, multi output, as well as sequential and combinational. Okay. Now, in order to solve the real world problems using the digital system, we need to have some kind of process. We will see that the first step is you should represent that real world problem as a Boolean expression. In other words, you should capture the behavioral aspects of that physical problem and get the Boolean expression. So in this case, how we can consider it? We say that the real world problem inputs are basically analog, and hence you need to convert to digital, and this in turn is going to be used for devising the behavioral aspects of the problem, and we tabulate it. We call that as truth table. And from truth table, you devise the Boolean expression, and this Boolean expression indeed is going to be subjected to the hardware while solving it, and the solution of the digital Boolean expression is going to tell what is to be performed. It won't do the action, what to do, because its strength is not much, it won't perform the action. In broad, we can say it is only a switch. It can be either high or low. It will tell what is to be done, and the answer of the digital Boolean expression can be either true or false, or 1 or 0. You can say 1 means close and 0 means open. This in turn is going to take the help of another electromechanical gadget which is performing actual work. We call it as actuator, electromechanical device. It in turn is going to provide a solution to the real world problem. Now once again we go through the process. The analog inputs of the real world problem are first converted into digital, and from the behavior of that real world problem we devise the truth table. From the truth table a control expression or a Boolean expression is devised, and then a set of gates are used to solve that Boolean expression, and it is able to provide a solution. The solution can be either 1 or 0, true or false. This only tell what is to be done. It won't perform the action, and hence we should take the help of another gadget. We call it as electromechanical device that will perform the actual work, and it will provide a solution to the real world problem. So now I hope it is clear. First, what we have seen, what are the types of digital system, and second one, the process of solving the real world problem. Next we take one example, simple example. Okay, the flow can be like this: input signals, truth table, Boolean expression, the digital hardware, and then it will tell what is to be done, and finally actuator is used to perform the actual work for providing the solution to real world problem. Okay, we take an example. Here it is, we call it as bank chest. Control or open, close, etc. Any name you can give it. BCC. It's not board of control, cricket control. It is bank chest control. And this is simply tell whether the chest is open or chest is closed. Chest is nothing but it's a money where the money is going to be stored. You can say almanac, etc. From that, every day the cashier has to draw the money, take the money, and put the money back into that safe place. Okay, y equal to 1 means chest is open, and y equal to 0 means the chest is not open. Okay, first I try to give the behavior of this banking problem. Every day morning the cashier has to open the chest and take the money, and at the end of the day whatever the amount that is present at cashier has to be stored back into the chest. The process that is used to do this activity is simply, or the process for chest operation, bank chest operation, is simply given by the following rule. You can call it as a rule or a protocol or whatever the name you can say it. So what that rule says? In the presence of manager, one of the clerk cashier otherwise has to open the chest. So this is what the protocol or a rule. Now we consider the three variables, three inputs for the system A, B, C, and A happens to be the manager and BC happens to be the cashiers. So what is mandatory here? In the presence of manager, that means manager must be there and any one of the cashier, either B or C, must be present to open the chest. We are going to see the control expression is simply y equal to AB plus AC. Okay. So this system is having three inputs and we try to derive the truth table for this system based on its behavior. The truth table is nothing but associating with the inputs as well as the output. Three variables, 8 combinations are possible: 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. We'll see it. So what is the meaning of 0, 0, 0? None of them are present. So we'll say present. Presence is 1, not present is going to be 0. Neither manager is present, nor the first cashier is present, nor the second cashier present, and hence there is no question of opening the chest. And hence chest is not opened. 0, 1, 0, 0, 1. Since the manager is not present, and hence there is no way of opening the chest. Again 0, 1, 0, only one cashier is present B, but manager is absent and hence chest cannot be opened. Again 0, 1, 1, only cashiers are present but manager is not present, again chest is not open. And hence all these four cases we can say manager is absent, is not present, and hence chest cannot be open. Now come back. 1, 0, 0, only the manager is present in this case. What we say is, along with the manager, one of the clerk must be present since both cashiers are absent and hence we say that chest cannot be open. I am using the clerk as well as cashier synonyms. So please take it, cashier and manager. So 101, indeed the manager is there as well as second cashier is present and hence the chest is open. It satisfies the rule and hence chest is open. And 110, again it satisfies because manager is present and cashier B is present. 111, both the cashiers as well as manager is present and hence this is going to tell the chest is open. So all these three cases, it simply say the bank chest is open or open. Now we want to give a mathematical expression for this opening of the chest. So how we can say here, y equal to manager must be there, that is there, any one of the cashier must present. So this tells manager presents and this is going to tell either cashier B or cashier C is present. And if I little bit of expansion, it is going to give me AB plus AC. So this is what we have seen in the previous beginning. So the control expression y equal to AB plus AC. Thank you. This has given the basic introduction of the digital system and what are its applications and what a digital system can do. What are the types of digital system? And I have mentioned some applications which we are going to see in the next session. Headlight warning system, door locking alert system, railway signaling system, and furnace cooling system, etc. And next what we have seen is what is the various types of the systems: single input, single output, single input, multi output, multi input, multi output, and combinational as well as sequential. And finally, what is the process of solving the real world problem and how to represent the real world problem as a system, inputs and outputs, and what is the process associated conversion analog to digital, conversion, truth table, hardware, solution, activator, and sometimes here you can use the digital to analog converter that will perform the actual work. Or some people say the D to A is a part of this activator. So it is going to control it. And the flowchart is shown. And one sample example, we have seen the bank chest opening system. And the principle is in the presence of the cashier, in the presence of the manager, one of the cashier must present to open the chest. Chest is nothing but it's a place also containing the money. You can say it's a treasure. Okay. Uh, every day the bank people have to operate it. Thank you.